doesn't look like brown.
It looks like his shirt has a lot of dandruff on it.
Okay, so we will get this show on the road. I want to welcome the audience. Thank you for coming. This is going to be, I believe, the 7th, the 8th out of 23 talks. So we only have another, 15 or 16 left. Anyhow, and to remind you that we are going to have Dan Larson will be talking tomorrow at 3:10 in here. And then if you want to see talks next week, every afternoon except for Monday afternoon, we'll have talks. And the week after, every afternoon, we'll have talks as well. The people in 680, here's your sign-in sheet, so you can sign in there.
All two of you, thanks.
Okay, well, that's, we're making progress here. We're making progress.
Yes.
And so it's my distinct pleasure to introduce Shay. I've had the pleasure of having Shay as my advisee for many a year now. And that she got me hooked into, and my kids, hooked into gaming house. It's absolutely fabulous. And speaking of which, we will show up tomorrow.
Yes.
It would kill me otherwise.
Perfect.
And so it's been a distinct pleasure having Shay as in class and as an advisee. She's hails from Madison, is going to take a year off collecting experience so that she can successfully get into PA school. It turns out you have to have about 500 patient contact hours, which is very difficult to do unless you have lots of patients at school. Anyhow, without further ado, I will turn it over to Shay.
All right. So I am Shay. Thanks, Dave, for introducing me. I'm going to be talking about the proposed anticonvulsant mechanisms of the ketogenic diet. And yes, that is a mouthful. So to break down a little bit, the anticonvulsant part of that is, so you can have this convulsion before seizures happen, and it usually precedes all seizures. So if you cut down the amount of convulsion, then you can cut down the amount of seizures for epileptic patients. The ketogenic diet is a particular diet that I will be talking about very shortly. And the proposed mechanisms, because they haven't actually figured it out yet. So, take it step by step. This first image is a functional MRI image, and the left-hand side is in a normal patient. The right-hand side is in an epileptic patient, so this is two different people. And an fMRI shows blood flow within the brain. So things that light up really hot, like really yellow or white even, is a lot of blood flow, and things that are black or very dark red is low to no blood flow. So this first image, you can see that it's kind of averaged out in the entire brain. And in the second one, you can see these really, really hot spots up here in the top right-hand corner. And you can see where the arrow is pointing, where there's really no blood flow at all. And in this particular image, they thought that that was because of damage to the brain because of all of these seizures that patient has been having. So just a quick definition of epileptic seizures themselves. Brief episodes of abnormal excessive neuronal activity. So just like I was saying before, the really hot spots that were in that corner, that's the excessive amount of activity. You can also look at the amount of activity in the brain with an EEG, which is short for electroencephalogram. And that means that they're looking at the electronic activity within the brain. So when a neuron synapses or sends a signal, then you can record the little brain waves on this machine thing. And on the left-hand side is all normal activity, and then right about the middle here is when the epileptic seizure hits, and the right-hand side is, super jumpy and ridiculous, and that's the seizure happening. So lots of excessive, abnormal amount of brain activity. And a little image on how a neuron fires. It goes from the cell body, which is that big round thing, and it goes through the axon to the next neuron, another big cell body. So large chains of neurons, and the synapse will fire through a bunch of them in order to have that signal go through. A little bit more about how a neuron works. Like I said, big cell body, axon, it goes to the axon ending, and then you have another cell body here, and it just perpetuates that signal. So a depolarization event is what causes that electric current to go through. So this cell body will depolarize, which means that a stimulant attaches to the cell body and causes a signal to go through. So as soon as like a neurotransmitter or pressure, even pain, will stimulate that cell body, and a synapse will go through, fire through the axon to the next one. And the most important thing here is the myelin sheath. And this is really important because it protects the axon, and it also helps that synapse fire correctly and for the signal to go through. The reason why this is important to my talk is because they're made out of lipids. So there's fat that surrounds the axon, that's the myelin part. It's about 50 to 60% made up of lipid. And something that can happen is demyelination. So if you strip off all the myelin off of this neuron, the neuron will stop working, which is really bad. Something that can happen in the brain is lipid imbalances. So that demyelination is a type of lipid imbalance. And like I said, many diseases are caused by lipid imbalances. So epilepsy is included in that. Dementia, Alzheimer's, Huntington's disease, all of these can be caused by lipid imbalances in the brain. Lipids are super important, not only for the myelin that I was talking about, but all of your cell membranes are also made out of lipids. And most of the hormones within your body are made from lipids. So it's really important to keep your lipid concentration to a level where you can have all of these things working correctly. The last thing is lipids are super vulnerable, and it's really easy to get them to degrade. And one of the things that degrades lipids are reactive oxygen species. So RS stands for reactive oxygen species. And these little guys up here, this is happy oxygen. So all of these two molecules, all of their electrons are paired together, they have a buddy, they're really happy, they're floating around in the atmosphere, they're good to go. But you also have angry oxygen. So these reactive oxygen species have this lone electron over here. All of these have little lone electrons, and they're really angry. They get mad, they like to attack things, so they like to attack lipids. They also like to attack, your cell membranes, and it makes your cells explode, and very bad things happen. So all of these reactive oxygen species make oxidative stress within the cell. So an ROS will come into the cell and make the cell angry because these electrons that are mad at each other will attack other things, and then it makes the whole cell angry, and the cell will either explode or it'll try and get those reactive oxygen species out of there, that kind of thing. So ROS are made in the mitochondria. The mitochondria are little things in the cell that make energy, or ATP. And one of the most important things about this is that the brain has lower antioxidant defenses than anywhere else in the body. So usually your cells can make antioxidants themselves because the mitochondria makes these ROS things. So the cell has then produced this advantage to make antioxidants so that it doesn't damage as many cells. So how do the mitochondria make this ROS? So we're just going to go through mitochondria and the TCA cycle really, really, really briefly. So you take in glucose from your diet, like carbohydrates, some proteins you can make glucose from proteins. And it goes through glycolysis, and this is within the cell. And then the product from glycolysis goes into the mitochondria, into the TCA cycle. The TCA cycle then makes ATP for energy. Yay! But what happens if you don't, so it makes ATP, but if the mitochondria is doing this a lot, it's getting really stressed out, it'll make these reactive oxygen species, which is bad, very bad, angry, like before. So, if you don't have glucose, this is part of the research I'll be getting into, if you don't have glucose and you use ketones instead, the ketones get fed right into the TCA cycle and make ATP, and the mitochondria is a lot happier with that because it doesn't have to do as much work. So possibly you don't have as much reactive oxygen. So a little bit more about the ketogenic diet. The classic ketogenic diet induces ketosis, which means the thing I was talking about before, ketones goes into the TCA cycle to make energy. That's all ketosis is. So ketosis uses those ketone bodies, and what it does is it takes fatty acids. So this is just an example of 3-chain. It can be you know, like a 2 chain or a 500 chain, you know, like large molecules of fatty acids. And it creates ketone bodies out of those. This is 3 different examples. You don't have to memorize those. I'm not giving you a test. So it uses these ketone bodies instead of glucose in order to create ATP. A little bit more about how the ketogenic diet encourages production of ketone bodies from fat. The ketogenic diet is a 3 or 4 to 1 ratio of fat to protein and carbohydrates. And I know what you're thinking. What? I'm eating 3 to 4 times more fat than anything else? Why, yes, you are. In this particular diet, it's about 65% fat from calories, and the rest is supposed to come from protein, little to no carbs. And I know what you're thinking, but fat's bad for you. The FDA said this. Stop. Fat is not actually bad for you. If you search for dietary fat on like Google Scholar or even Google itself, that's fine. You'll get over 10, 20 different pages of results. And a bunch of this is research that has been done that's about obesity, coronary heart disease, insulin resistance, dementia, Alzheimer's, strokes, those things I was talking about before. And all of them, they're affected by dietary fat, and it makes all of these things a lesser chance of getting them. So if you have higher dietary fat, you have less of a chance to get obese. You have less of a chance to get coronary heart disease, that kind of thing. So fat is actually good for you. A little bit more about the ketogenic diet. Like I said before, ketogenic diet is 65% fat, about 25% protein, and 10% or less of carbs, compared to the FDA recommended diet and the low-fat diet, which I don't know. So the ketogenic diet was first used in the 1920s to treat pediatric epilepsy, and this was because anticonvulsant medications had not come out until about the 50s or 60s. So they were using this, you know, way before anything else came out. And again, comparison to these other ones, it's very different, I know that. But I've actually been on the ketogenic diet since September. And I don't have epilepsy, but it's been shown that if you have diabetes that runs in your family, like in mine, type 1 and type 2 in both sides, you can have a lower chance of developing diabetes. And even if you're pre-diabetic and then you go on the ketogenic diet, you can reverse that pre-diabetes. So this is pretty huge. It's pretty new research as well. It's been done within the past 2 years. So I'm trying it out, and I'm, you know, still here and healthy, so it's not bad for you, I promise. And many studies have been done on, you know, how well it works and what kind of things should I eat and shouldn't I eat, and, you know, talking about all that stuff. But the big question is, how does it actually work? And no one's been doing a ton of research on this because it works. So let's do it. It works. But how does it work? So this particular paper that I'm looking at, it came out in 2008. They use the meta-analysis method. So you have all of these studies that have been done before, and what you do is you take them, you put them all together, you look at all the results, you go through them, and you take out the stuff that you want, you push away all the stuff that you don't want, you go through it, and you then put it together in a way that people haven't seen before. So you can draw out new conclusions, think about stuff in a different way, that kind of thing. So the first page of results that they had, I know this looks kind of daunting, I promise, it'll be fine. So they looked at age, and in experimental findings, this was all done in rats or mice. And clinical findings, they got a bunch of papers that were done in like Denmark, Sweden, here in the US, like basically all over the world. And they looked at, you know, actual epileptic patients. So age, really no difference between you know, young people and older people. Seizure type, again, no real difference. You know, equally effective between different types of seizures. Dietary composition, this is talking about strict ketogenic diet versus, you know, like a low-carb Atkins approach to a different type. All of the so all of the different diets that are still higher fat, but it plays around with the amount of carbohydrates and protein. So the dietary composition doesn't really affect the outcome as well. The ketogenic diet ratio, that's what KD stands for, is ketogenic diet. The greater the amount of fat to the other things, the greater the anticonvulsant effect. So if you have 4 times the amount of fat versus other things, it'll work a little better than 3 times the amount of fat to other things. And then calorie restriction is the last thing on here. Calorie restriction by itself is also an anticonvulsant. So when they put it together, you have the greatest amount of anticonvulsant effect. So they also looked at growth rate, just because this did come out for pediatric epilepsy first, so they wanted to look at how the ketogenic diet affects growth in children. You would first see an initial decline in growth, but then the normal growth rate resumes pretty shortly thereafter. And they actually looked at, there's a really cool study that was done where they, these children started the ketogenic diet, and doctors kind of estimated what their height would be at the end of it, and they were within like 1 inch to 1.5 inches of what they hypothesized. So really not a huge difference in growth rate. And then latency to ketogenic diet, that's how long it takes for you to get to the maximum effect. So it's about 1 to 2 weeks, but in clinical findings, the reduction of seizures can happen in 1 to 2 days. So pretty drastic in the beginning, tapers off, and then you have the maximum effect within a week to 2 weeks. The reversal of ketogenic diet is just basically the opposite of what I just said. So how long it takes for you to get back up to the initial threshold of the amount of seizures that you were having. That's, again, 1 to 2 weeks, but in those clinical trials, they actually found that with small amounts of carbs, so let's say you're on the ketogenic diet for 6 months, because that's a good amount of time to have the maximum amount of effect. And then you have like 2 pieces of bread with your dinner, you can have a breakthrough seizure within like 10 to 15 minutes. And they can be pretty severe as well. So that's something that's interesting to note. And then last thing, gender, males versus females, doesn't really matter. It produces the similar effect across the board. So a little summary of all of that. Generalizations that they came to. So the anticonvulsant effect is strongly linked to the calories. So that calorie restriction I was talking about has to happen in order to have that anticonvulsant effect. The ketogenic diet has to be strictly adhered to. So if you don't strictly adhere to it, you'll have more breakthrough seizures, which can be really scary. The calorie restriction can work with the ketogenic diet in order to reduce the seizure amount, and that seems to be how you optimize this treatment if you're just doing the ketogenic diet, is to do the diet plus calorie restriction, and then you have the maximum effect. You have to have that adaptation in order to have the maximum results, and it's effective for lots of different epileptic conditions, different types of seizures, and it's independent of gender and age. So again, we're looking for that anticonvulsant action, whatever stops or slows down that uncontrolled activity within the brain. So going back, so we've looked at all of these different studies, and the results were, this analysis and appraisal. So then you want to look at their systematic review, which they had this beautiful, beautiful diagram that if you are not sitting there for at least half an hour, you don't understand. So I broke it up. So again, we're looking for how this happens. Ketones to the TCA cycle to create ATP. What about this that we don't have any glucose within the body? What happens that we don't have that reactive oxygen species within these cells? Because that's what does the most damage. So the first mechanism starts with the free fatty acids, and this just means you're taking in more dietary fat, so you have more of these fatty acids around to use them for energy. The first is you go into chronic ketosis. So the thing I was talking about, you use the ketones for the TCA cycle into ATP. You're making energy. like I said, modifies your TCA cycle. You're skipping the whole glycolysis and all that junk that comes before the TCA cycle. So it doesn't stress out your mitochondria anymore. You're having that decreased reaction of oxygen species, and you also increase this GABA. It's a neurotransmitter that is inhibitory. It's the main inhibitory neurotransmitter. So increasing that, you have a lower chance of having those epileptic seizures because it's inhibiting across the board pretty much. The other one is about the reduced glucose. So the two different sides, you have more fats and less glucose. So the other side of this is the reduced glucose. You first have the decreasing glycolysis, again what I was talking about, the TCA cycle, no glycolysis. So then you have this change in the potassium channels, which means that you are hyperpolarizing those neurons. So if you think back to one of my beginning slides, those neurons then have to have more stimulation in order to fire a synapse. So if you have the reduction in potassium channels, it takes more for that neuron to actually fire, and then you have a lesser chance of having that uncontrolled activity. So like I said, it hyperpolarizes those neurons. It takes a lot for them to fire more often, which causes the seizures. So where do we go from here? I tried looking for more studies that were done later than 2008 on these particular mechanisms, and there really aren't a ton yet. So I kind of just extrapolated from what they were saying, and they said we can optimize and streamline this diet for epileptic patients. Since we have so many studies on how well it works, we can then fine-tune it and make it just as good, if not better, than some of the anticonvulsant medications that are on the market. You can also look at new treatments for epilepsy. So since there's so much on this ketogenic diet, what if we look at some other types of diets that might do the same thing? Or since we're understanding the mechanism of this particular treatment better, then we can apply that to other treatments that we already have and perhaps find new ones. We can also use these therapeutic diets for other diseases. So those diseases I was talking about, stroke victims, Alzheimer's, dementia, Huntington's, perhaps we can use these similar diets for those as well. We can also look at how complex. We don't actually know all of the different mechanisms for metabolic activity. So in order, understanding how the ketogenic diet works for epileptic patients, we could then look at more of those metabolic activities and look at the actions that happen because of that. So if you have any questions, I'll take those. I do want to thank all of my classmates in the Cheminar course, Dr. Dave, Dr. Deborah, and Dr. Stork for all their help getting me through chemistry. So yeah.
Questions?
Questions? Yeah, Sarah.
So you mentioned that the ketogenic diet can be good for people who have history of diabetes.
Mm-hmm.
Are there any other studies on different things that it can be helpful for, or even just in people without any sort of disorders?
Yes. There have been a couple of very small studies, so you can't generalize to a larger population, but they've looked at PCOS, people with PCOS, so it's women who have a lot of cystic activity on their ovaries, and how that can this diet can reduce some of those side effects from that. They've also looked at how well people can lose weight with this diet, because fat will, in very layman's terms, fat will fill you up longer because it takes your body more time to break them down, so it'll keep you fuller for longer, so that kind of helps with the losing weight kind of thing. But like I said, it's pretty small studies that they've done so far, so you can't really generalize or extrapolate from there. So, but they have done that. Yeah. Yes.
So I know from being around you, well, you've been on this diet, and then I also know from my own personal experience that there's a growing kind of awareness of like lactose intolerance and not being able to handle lactose or casein, which seems like it would be a really large part of this diet. At least it is for you. And I'm wondering if there's like dealing with that awareness of like our bodies not being able to all handle the same enzymes and that kind of thing, and then diets like this that like depend on a large intake of similar enzymes, and you know what I'm asking.
Yes. The thing is that people think that the ketogenic diet is really limiting, and the thing is that it's not really. Yes, you can't have carbs, but that's only, you know, like this little subsection over here of food. So there's actually people that do vegan ketogenic diets, and that's super limiting, but you can do it. So the things that you can eat that have a lot of fat in them that are natural and not, I guess, not as processed as dairy is usually. You can eat a lot of nuts, avocado, different types of oil. Veggies are awesome, you know, and then you just add extra like olive oil on top or something like that. So it's very, you can tailor it to your own tastes. And actually within clinical setting, it's kind of terrifying. You go to the hospital with, you know, like your epileptic child, and stop it. You go to the hospital with your epileptic patient, and you hand them over to the doctor, and then you leave them there for 3 days. So they have no food or water intake for 24 hours, and then they start this thing called medium chain triglyceride oil, and that's all they have for a day and a half. And it's like a fast way of getting them into the ketogenic diet. So it can be even more limiting if you need to do it for, if you need to do it for those type of reasons. So it varies a lot within this. Yeah. Yes.
And so what about just eating all McDonald's? Because I mean, in theory, you could just have lots of French fries and.
That's carbs.
Huh?
But that's carbs.
Well,
Just meat patties.
yeah, just meat patties then. There you go. Well, but that's just protein. I guess to rephrase it is what about the quality of the
fat.
the quality of the fat, the quality of the
Yep.
protein. I mean, you know, you're 25% in protein. It could be all beef.
Yeah, it's true. That's something that you have to be careful with because, you know, like trans fats obviously are very not good for you. And you should probably limit saturated fats as well. It very much depends on the types of fats and proteins. So the things I was talking about earlier, the nuts, avocados, and oils are much better than like butter, even though I love butter. And it's also better than, you know, drinking a giant latte of heavy cream every morning or.
But what's wrong with the butter and what's wrong with heavy cream? Because you just said fats aren't bad, so.
Yeah. It's definitely the types of fats. You want to go for unsaturated fats versus saturated fats, and that's a whole nother slew of metabolic processes that I could go into. But you want to limit those. So if heavy cream and you know, beef were the only things that you ate, you're going to have problems. So you want to limit those. You can still have them, but not in large quantities to have a balanced diet overall. Yeah. Yes?
What is an ideal meal for you in my situation?
Ideal. So, okay, now I'm hungry. So like a giant plate of like, you know, this much of broccoli. Love broccoli. Love cauliflower. They're both great. With, you know, like some roasted garlic olive oil, which is my favorite thing in the world. And then you can put like a little bit of cheese on top of there, a big piece of fish on the side. Basically just like veggies and lean meats with a little bit of extra fat thrown in there. No soda, no fruit juices. The fruits that I eat for like dessert, because I don't really eat dessert very much, even though Sarah made some awesome cookies in the back, those are actually ketogenic. I usually you know, like sliced berries with toasted almonds and a little bit of heavy cream, or fresh whipped cream that doesn't have any added sugar in it, that kind of thing. So it's all very normal sounding when you just say, like, these are the foods I normally eat. It sounds a little strange when you put it on paper. Yeah.
So in the cartoon picture of the conversion from the glucose to the ATP, and so with this ketogenic diet, you don't have to worry about those ROSs. So does that mean you also don't have to be as concerned about consuming antioxidants? Like they always tell us, oh, the more antioxidants you have, the more is that what you would be getting rid of if you did consume them? Or?
I mean, it doesn't completely eliminate the reactive oxygen species, since those can happen, you know, going out in the sun and you're damaging your DNA. You know, it happens just on a regular basis. But you're limiting them, so it is a little better, I guess, if you're looking very broadly like that.
But it also sounds like the foods that you're suggesting, aren't they those classified as being high in antioxidants? So is there a difference between, is that this ketogenic diet reduction of the ROS as a result of their antioxidant power, or is it that there's already a lack of antioxidants?
Yeah, and that's, no, Sarah, this is my talk. Okay. The thing is that a lot of these clinical findings are looking at that hospitalization that I was talking about, where it's the fast track into the ketogenic diet. So for patients that have really severe epilepsy, they go on this diet, and that's what they do, is they just have this MCT oil, and then they supplement it with, you know, like a small piece of chicken breast or a small piece of fish, and that's what they do.
And they still see a reduction.
And you still see a reduction in the reactive oxygen species. Yep. Sarah, you wanted to say something? Yes.
Well, like, they have actually found, at least in rats and mole rats, that the amount of antioxidants that they eat isn't correlated to the amount of reactive oxygen species and oxidative damage. So it's actually thought that it's questionable whether or not eating antioxidants even has an effect.
Which then gets us to my question. So,
Okay.
so we'll go geek speak for just a minute here. So we read the Ross versus mTOR paper.
Yes.
And so the reactive oxygen species probably aren't all that important, although this is what they're pitching in this paper. Have you found anything about autophagy and mTOR reduction with a ketogenic diet? Because
Yeah,
that I would wager my money that that's more important than even the Ross.
Yeah, that was something that they mentioned in this paper. Like I said before, they had this giant, it's a beautiful graph of all the different pathways that they looked at and they went through. I focused on this one just because, you know, people are more familiar with antioxidants and how that works, so I wanted to, you know, kind of show what reactive oxygen species were, so you kind of understand why you're eating these antioxidants, supposedly. So they did a little bit on mTOR, but there haven't been as many papers on the mTOR activity with an autophagy and that kind of thing with this particular diet. So it is something that they could look at, which would be super interesting to compare them to, you know, this paper that focuses on reactive oxygen. Yeah.
Right. Well, high intensity training actually ups ketone bodies, which is one of the interesting things.
So you put the epileptic children on treadmills and have them sprint and then have, yes. Okay.
Precisely.
Yes.
Are there any known side effects to this sort of diet? I mean, you've given the positive. Are there negative things you have to watch out for?
Not really. They've been looking, like I said, these efficacy studies have been going on since the 40s, and there have been people that have been on this diet since, you know, the 40s and 50s, and there really doesn't seem to be any sort of side effects other than you can't run marathons because you don't have those glucose stores anymore, so you can't, you know, have sustained amount of energy unless you are like continually eating throughout the marathon. That's about it.
Right. I would imagine it's also quantity and quality of what you eat that's going to make the biggest difference. Any other questions? Okay, thank you very much.